So welcome everybody who's joining us from YouTube. So we just had a discussion over if there were any questions, adjustments. And so some of the summaries, I'm gonna look into posting some grades on Play-Doh or some sort of summary of what happened before we went remote. But from here on, most of our grades are on web work. And so you should be able to see the summaries that are up there. And I'm going to adjust some of the rounding that appears. So right now we are in section 2.5. So I'm going to go ahead and share my screen and start talking a little bit about what we're doing in section 2.5, where we talk about the chain rule. Okay, so here is our virtual Blackboard. And so chain rule is a rule where we're going to be dealing with function composition. Okay, so we've talked previously in section 2.4 about product rule and quotient rule. So how do we take the derivative when we multiply two functions together? We've previously before that talked about what do we do when we add or subtract or multiply by a constant. And so the other thing that we need for rules is function composition. So what does that mean? Usually we use notation that looks something like this. And we have some sort of inside function, right? We're going to put one function inside of the other, right? So g in this case would be our inside function, and then f would be our outside function, okay? So you'd have something like this, where you have one function that's being plugged in to another function. So if you want to reflect on something that we did before, when we were taking derivatives by definition, we were looking at terms that were something like this, f of x plus h, where we were plugging x plus h into some other function and then evaluating and looking at it that way. And so this was a form of function composition where we have not just x, but we have some other function. In this case, our function was x plus h. We were plugging it in to something else. Okay, so to give you an example of what function composition is, to reflect on this, let's take two functions. Let's let f of x be equal to 3x plus 2, and let's let g of x be equal to tan or tangent. And we could ask questions like this one. We could say, hey, what is f of g of x? And so what we're saying here is we're going to take g of x and we're going to plug it in to f of x. And so this would look like we would have, so let me back up here. So we'll erase this. So we have f of, right, g of x is actually going to be tangent. So we want to take the tangent function and we want to plug it in as an input to our new function f of x. And so what we're going to do is if we come over here, every time we had an x, right, whatever our input was for f, we're going to replace that with our tangent function. So it looks something like this, right? We have 3 times something plus 2, and inside this spot right here, that's where our input is going to go. So this tangent has to go in here. Okay, so we would get 3 times tangent x plus 2. Okay, so let's go ahead and we can see if I can move all this stuff quickly. So at home, why don't you go ahead and try to do this the other way? So we'll take a minute here and try out this one on your own, right? So g of f of x. We're going to compose them the other way. So instead of having g as our inside function, we're going to flip it around. We're going to have f as our inside function. Right, so I'll give you a minute to think about this, and then I'll go ahead and put the answer up here. So I've written it out here, and just to spotlight some things, right? We see that our f of x is our inside function is 3x plus 2, right? So that's what we use to plug in, right? We're plugging 3x plus 2 into our function g of x. So the first step, I just replaced this, and I said, hey, I want to know what g of 3x plus 2 is. And this input gets plugged in for the x up here inside of our tangent function. And so the composition will look something like this, tangent of 3x plus 2. Okay. All right, so what we can do is we actually want to think about this in the backwards order. So instead of being given the two functions, f and g, what we actually want to do in calculus is we want to think about this in the backwards direction, and we want to be given the ending spot here, right? So we're going to be looking at functions that are composite functions, and we want to break them down into their f and g parts, right? So if I were to give you this right here, tangent of 3x plus 2, I would want you to tell me, oh, the inside function is 3x plus 2, and the outside function is tangent. Okay, so what we'll do is I'm going to put up a function here, and I want you all to think about, hey, what's our inside function and what's our outside function? Okay, so here is our function. We could see something like this, e to the x squared plus 7. Okay, so I'm going to call this function h of x. And I want to rewrite this. Okay, so I want to look at this as something like f of g of x. I'm going to look at it as a composite function. And I want you to tell me what f of x is equal to and what g of x is equal to. Okay, so the key here is there's not just one answer to this question, so there could be a lot of different ways to write it as a composition, and you have to identify one of them. Okay. So take a minute here. What's our inside function? What's our outside function? Grab our chat here. Okay. All right, so for this one, when you look at it, you should see, hey, inside here, right? So what I'm doing is this x squared plus 7 is acting as an input, right? This is acting as an input to the function e to the x. So if I break this down, I would look at this and say, hey, our outside function, right? So my outside function is f, is e to the x, and my inside function is what's going on up here, is x squared plus 7. Okay, so when we look at function composition, just like we did for product and quotient rule, when we take the derivative of this, we're going to want to identify these two separate pieces, because the derivative of this function is going to depend on f, it's going to depend on g, and we're also going to have to do f prime and g prime, just like we did for product and quotient rule, right? And so there's going to be some formula that we put these things together. Okay, so let's go ahead and, whoa. So let's just try to scroll here, right? So we'll put this down. Let's try one more. Okay, so if I put up this, I put up tangent of 5 e to the x plus 9. You'd want to look at this, and we would want to break it down into, hey, is it a composition? And if it is, what's the inside function and what's the outside function? Okay, so what I would see here is I would want to write this as, hey, this is going to be f of g of x for some f and for some g. And I hope you're thinking about these as we go along. So in this case, our outside function would be tangent of x, and then our inside function would be 5 e to the x plus 9. Okay. All right. So far, so good. We want to check in, thumbs up. on our screens here? Emily's good. We feel good about this. Excellent, excellent, excellent. Okay. All right, so what I want to do is I want to look at another activity. So I'm going to switch my screen share here to our book. Okay. Can you all see this reasonably well? You can see our book here. Okay, so activity 2.5.1 here, what the idea is, we're going to go through, and just like I worked through a couple of examples, we are going to look at A, B, C, D, E, F, and you want to identify these as function composition. So if there is function composition, then identify what's the inside function and what's the outside function. And then if it's not function composition, we're going to go ahead and we're going to take the derivative and see what we can do. So if you can take the derivative, you should do that. And if you can't, meaning we don't know, we don't have quotient or chain rule yet. So if it's a composite function, you should identify what the inside function and the outside function are. Okay, so one of the things that has been troubling me and other people is our sort of inability to write on a shared whiteboard, especially in calculus, when some of these things, the notation, we really want them to be sort of typeset pretty well. And so I thought, I was talking to some other people at Westfield, and they came up with sort of an ingenious solution, which was to use Desmos to typeset things. Okay, so if I wanted to typeset certain things, what I could do is I can actually use this sidebar over here to typeset different things. Okay, so let's go ahead and if I want to look at this, if I want to typeset it nicely, so tangent of 2 to the x, so our job is to look at this and identify, hey, is this something that I can take the derivative of, or is it function composition? So tangent of 2 to the x, if I wanted to typeset it, I could write this, right? So you can sort of ignore what's going over here on the graph, but if I just want to type math, right, and I want it to be typeset nicely instead of having to, draw with my mouse, this is a nice way to do that. Okay, so what I could do is I could check, hey, this is tangent of 2 to the x. My inside function, my f of x here would be 2 to the x. So sorry, we were doing it the other way. So our outside function in this case is going to be tangent x, and our inside function is going to be 2 to the x. Okay, so what I'm going to do is I'm going to split us up into breakout rooms so we can have a chance to think about these a little bit slower pace with each other. And this is one option. So if you like the shared whiteboard, right, so if you want to continue with the shared whiteboard, absolutely do that. But if this is also another reasonable way to share our typeset math. So if somebody wants to share their screen and sort of act as the note taker or something, this is one way to be able to do that and share in a reasonable way. Okay, so bring up this one, preview activity 2.5.1. Again, the instructions are identify function composition if it's there. So we've done A together. If it's not there, so like this one right here, there's no function composition. You should identify this as product rule. So then we would take the derivative of that function. Okay. All right, so let's go ahead and set up breakout rooms. We're going to be in 3 rooms, and there'll be 3 people. So when you get to your breakout rooms, there'll be 2 other people there with you. And sort of let's take 10 minutes and let's think about this 2.5.1. Okay, so I'm gonna open up all your rooms. So go ahead and join those, and I'll float around and answer questions, and then we'll come back together here in 10 minutes.
How do we get the whiteboard?
Hello.
Hello.
How do you get the whiteboard? Okay, so if you want the whiteboard, so I think it works best if somebody's on a laptop. So at the bottom of your screen, you would hit share screen, and then it's going to pop up a menu, and one of the options is going to be whiteboard.
Cool.
Yep. So Erica, you got it here. Okay, so if you have full screen on you, you can hit view options up at the top and exit full screen if you want, or you can click on annotate, and then we can all write here, right? So you could write something like this.
Okay, so everyone has access to it?
Yep, everybody who clicks annotate, so under the options, then you have the ability to write on the whiteboard.
Cool.
So do you all prefer this whiteboard? It works out pretty well, or I mean, we can all draw on this one. If somebody shares their Desmos screen, you could presumably use that as a whiteboard as well. So
I like that you can type text on here too, though.
So you could do the same thing on Desmos, so you can still annotate. So let me, I'm gonna steal the screen share here, and so you can see the Desmos window here. So I'm gonna go ahead and I'm gonna turn off our functions, the grid, the x-axis, the y-axis. So go ahead and everybody click annotate on the screen share, and you should be able to then use this area over here as a whiteboard where you can write just like everything else. But for me, if I wanted to, I can still type over here. Since I own this one, I can typeset math. So instead of having it look like, you would type caret or whatever to represent exponents, you could actually have it look like it should look over here on the left-hand side.
Okay, cool.
Anyway, so we could do something like this where somebody has the ability to actually typeset the math, and then over here we can draw and draw or write or type or anything like that. All right, so I'm gonna stop this screen share, and I'm gonna give it back to you all, so you can take over.
Oh, thank you.
You are welcome. Any questions so far? Things are making sense?
Yeah.
All right. Okay, so I'm gonna jump in with another room. Hello.
Hi.
How are things going?
Pretty good.
Were you thinking about it together?
We're working on 2.5.1.
Yeah. So as you're working on it together, how are you sharing your work? Did you like the Desmos share mode, or?
We didn't try that out yet.
Yeah, we were just trying to look at these and figure a little bit of it out.
Okay. Any questions so far?
So you're saying like B, that one you can't, like that one's just normal. You can just derive that. But something like A or like D, you would have to put it into Desmos, right?
No, well, we will figure out the derivatives. So the rule that we have is called the chain rule that we're going to see here in a little bit. But we don't always. So one of the trickier things that's going to happen is once we have all the rules, identifying which one to use is going to be, eventually it's going to be the hardest thing for you to do, because you'll have the rules there, and then it's just a matter of applying the right rule. And so this is the first step towards that. So you have in this list of functions, some of them you can already take the derivative of, and some of them you can't yet. You will be able to here in 15.
So for like C, one of the functions would be tan x. That would be the inside function, and the other function would be x squared, right?
That's right. So the outside function would be x squared, and the inside function would be tangent.
So for B, there really isn't an inside or an outside function, right?
Correct.
So what would you?
So how are you combining are there two functions there?
Multiplication.
That's right. So if it's a multiplication, then that's when you would use product rule.
Oh, okay. So we're just figuring out that.
Yeah, so that's what you want to identify right here for this preview activity. So you're going to identify, hey, what rules, how are you combining the functions? Can you take their derivatives?
Okay.
And then if you can't, you should be identifying the places where you can't yet is when there's composition.
The new thing that we just learned.
Yeah, and so we'll see that the chain rule is how we use a chain rule to take the derivative of composite functions.
Okay.
So far, so good, Riley?
Yeah. I was just listening to what you were saying, and that makes more sense now. I was just looking at it. I was like, what am I doing?
Okay. All right. So keep going. I'm going to check in with the third group.
Okay.
Hello. How are things going?
I'm trying.
You're trying. Excellent. So, are you sharing when you're sharing work? Are you using the screen share feature at all?
No, usually he's just helping me because I just don't. I'm getting there.
All right. So, what do you have a question? Do you want to run anything by me?
No. I think I'm fine right now. Like I think I'm okay.
Okay. Bella, how are you doing?
I'm doing fine. I would just wonder if we could maybe go over maybe as a class, like, which one is it? E afterwards.
Yeah,
Yeah.
sure. Yeah, so we can. I'll do that one together. So E is so there's no composition in this one.
Yeah. So does
So
that
there's-
mean
You can identify that there's two functions there. One of them is square root of x, and the other is tangent x. And you want to think about how you're combining them. And in this case, you're combining them with addition. So they're not being composed, they're not multiplied, they're just added together. And so what we would do is when we take the derivative of that, you would look at each piece separately.
Oh, okay, so like the addition sign would just stay there?
That's right. Yep. So that was so when we looked at our early rules, we had the sum and difference rules. So it was like if you have f of x plus g of x, when you take the derivative of that, you just look at the derivatives of each piece separately. That's not the case for product, quotient, or chain rule.
Okay.
Right. So we can go over that one pretty quickly. But we're getting there. We've pretty much made our way through these.
Yes.
And that was the only one giving you trouble. So which ones did you identify composition?
B and E were the only ones that
B and E.
B and E are the only ones that weren't.
Yeah.
Yeah. All the others were composition. You were able to identify inside-outside functions. All right. So I'm gonna go ahead. I'm gonna call everybody back. So in about 60 seconds, let's come back as a group, and we'll see what.
Okay.
All right. So I'll see you over there in the main session. Caleb, I did it this time. I wasn't muted.
There you go. Not a rookie anymore.
Better. Thank you. Thanks for the applause. All right. So we had a request. So as I was checking with people, we wanted to take a look at one of these derivatives. So I'm going to go ahead and bring up our Blackboard here again. And I'll share. So the one in question was part E. And so part E of 2.5.1 said you have this function w of x is the square root of x plus tangent x, right? So when I look at this one, so I was talking to one of the rooms And we said, when we look at this, we want to identify how we're combining the two functions. So our first function is square root of x. Our second function is tangent x. And the way that we're putting them together is with a plus, right? So we're adding these two together. So there's no need to look at function composition here. It's not a composite function. And when I take the derivative, what I would do is I would take the derivative of each piece separately. So we have a chat here. And then we could do, so we can look at B as well, yeah. All right, so for square root of x, there's a couple ways around this. I think the most common thing to do is to first go ahead and rewrite, right? So you can rewrite the square root as x to the 1/2 power. So I can go ahead and rewrite this as x to the 1/2. And then for this part, I'm going to use just power rule. So the derivative, so we'll note this derivative is 1/2 x to the negative 1/2, right? So I bring the 1/2 down, right? The 1/2 comes down, and then I subtract 1. So 1/2 minus 1 is negative 1/2, plus then what is the derivative of tangent?
Secant squared.
Secant squared, that's right. Right, so the derivative of tangent is secant squared. So when I take this derivative, we would have the derivative of each part separately. And then request for B. So we had part B. So this was part E in 2.5.1. This is part B. So we have, let's see, 2 to the x times tangent x. Okay, so this one, when we look at P prime, we would use product rule. So I would set up my framework here like this, and I would look at my first function, right? Leave that alone, times the derivative of the second. So the derivative of tangent is secant squared. So this is fg prime, then I need to take the derivative of my first one. So this would be 2 to the x natural log of 2. And then I would go ahead and leave tangent alone. Right, so I'm going to grab a different color here. Right, so if this was f and this was g, we have f, and then this is g prime, and this is f prime, and this is g. Right, so we can see how that breaks down with the product rule. Okay. All right. So one of the things we're going to do is this is practice sort of identifying which rule we're going to use. And with one of the groups, I alluded that this is sometimes the hardest thing to do. So when we have a new function, once we have all the rules there, we're going to be okay. But then we still have to identify what is the correct rule to use or the correct tool to use in each situation. All right, so without further ado, let's go ahead and let's introduce the chain rule. Okay, so the chain rule is the rule that allows us to take the derivative of a composite function. So I'm going to take the derivative of something that looks like this, f of g of x. Okay, and the way that this breaks down is we're going to look at our outside function. So the outside function is going to be f of x. And what I do is, the first thing I do is I take the derivative of my outside function. Okay, so that's going to be step 1, take the derivative of your outside function. And I'm going to plug in, so I'm going to use my inside function g of x as an input to that derivative. Okay, so this is going to be f prime of g of x. And then to end it, we're going to multiply all of this by the derivative of the inside function. Okay, so this is our formula for chain rule. Okay, so I'm going to see if I can, all of this is grouped together. All right. virtual whiteboard skills here. Put that up into the top left so we can think about it. So, so we have that up there. That's our chain rule, but I think it's going to be helpful for us to then now look at an example. Okay, so if I wanted to use the chain rule, I could have a function that looks something like this. I'm going to take the derivative of sine of e to the x. Okay, so the derivative of sine of e to the x. So what I want to do is identify, hey, what is my inside function and what is my outside function? So in this case, we're going to go and say, all right, our inside function here is this e to the x, and then our outside function is going to be sine of x. So when I break this down, I'm going to say f of x, that's my outside function, is going to be sine of x. And e to the x, that's going to be my inside function, that's going to be g of x, is going to be e to the x. And when I look over here, there's going to be some other pieces that I need. So just to spotlight this, so I need to know f prime, so I need the derivative of f, so we'll get that. And I also need to know g prime, so I need to know the derivative of g. Okay, so when I come over here, I'm going to need, at some point, I'm going to need this f prime of x, which is derivative of sine, we know is cosine. And I'm also going to need g prime of x, and that derivative of e to the x, we know is just e to the x. So you can write this as e to the x times natural log of e. So I know some of us write it like this. E to the natural log of e is just 1. Right? So if you plug that into your calculator, you can think about that. So that's 1. So what I'm going to do is for here, for simplicity, I'm going to leave this off. Okay, since that's just 1. Okay, so when I put all this together, right, so this is saying we're going to have f prime of g of x. So I come down here and I need to identify, here is f prime. Okay, so that's f prime. And inside of that, I want to plug in this g of x. Okay, so this f prime of g of x is, I'm composing these two pieces right here. Okay, so I'm going to compose this. So f prime of g of x is cosine, f prime of g of x is cosine of e to the x. Okay, so that's my first part. And then I have to multiply by the derivative of g prime, right? So the derivative of g, which is g prime, and that's e to the x. Okay. So what we have is, right, so we have this f prime of g of x. That piece right there is this, right? So this is f prime of g of x. And then we have g prime of x, which is this piece right here. Okay. So this is how we do chain rule. So anytime you have function composition, I think to start out, what I really like to do is write out our functions down here. You don't have to do this every time. I think for a lot of us, it helps keep us organized. And then if you can think about this, you can think about doing this sequentially, that's okay too. Okay, so let's go ahead and let's try another example. So let's try our virtual whiteboard skills here. Okay. Oh man, missed one. Anyways, all right, so I'm not gonna spend too much time messing around with this. Let's take another one. Let's see if we can take the derivative of secant. Right, so let's take the derivative of secant of 2x plus 5. Right, so I'll give you all a minute here to think about this one. So identify your inside function, your outside function, and we'll go ahead and see if we can take this derivative. Okay, so I've set this up so far. How are we feeling so far? We've identified an inside and outside function. And then what we have to do is remember, all right, we need to take these derivatives. So derivative of secant, I picked this one in particular because it's a little bit tricky, right? So derivative of secant is secant tangent. And then the derivative of g, this is a linear function, so when I take the derivative, that's just going to be 2. Okay. So I expect that this is probably going to be a place where some people get tripped up. So what we need to do is I need to identify 2 things, right? So my quotient rule, or sorry, my chain rule looks like this: f prime of g of x times g prime of x. So I need to go ahead and I need to find this f prime of g of x, right? So I need to find this piece right here. So what I'm going to do is I'm going to put together this and this, right? So a common error that we see a lot is when I look at f prime, there are 2 places for the input, right? So there's this x right here. So whatever I plug in here has to go in 2 different places, right? So there's 2 spots for inputs in our f prime of x. So when you look at f prime of g of x, you want to replace, right? So this x, right? This x right here, this x right here is going to get replaced with 2x plus 5, which means you have to also put it here, and you're going to have to put it here. Okay, so when we take this derivative, you're going to get secant of 2x plus 5 times tangent of 2x plus 5. Okay, so this is f prime of g of x. That's what all of this is. Okay, so this piece is right here. Okay, so that's our f prime of g of x. And now the g prime of x is not much more to add on here, right? Right, so this is times g prime of x is just going to be 2. Right, so to complete our highlighting here, this piece, right, this g prime of x is this one right here. Okay, so this is the idea behind chain rule. You identify the function composition, what's your inside function, what's your outside function, and then we can use this rule up here to put them together. Okay. All right, so we are out of time, but before we go, let me jump back to our book, and I just want to give you some things to think about for Wednesday. So we're going to try to get through the chain rule in the next 2 days. So hopefully we can finish it up. But there are a couple examples right here. So 2.5.2, I was hoping to get through this today. We unfortunately didn't have enough time. But so think about this one for Wednesday. So for some practice questions, activity 2.5.2, try to go through these. You can also check them, right? So you know how to check them on Desmos. But see if you can do these 5 for Wednesday. And then what we'll do, I'll put it in my notes that we'll check in with this on at the beginning of class on Wednesday. Yeah, you should be okay. So if you look at chain rule, so if you can do these, then you should be good. So with the examples that I went through today, you should be okay to start the chain rule homework. Yeah. All right, so try out this, and then what you see, the next section, right? So the next part of 2.5 is we're going to put these rules together. So once we can do chain rule, now we're going to start seeing like a product rule inside of a chain rule, or a chain rule inside of a quotient rule, or something like that. And so that's what we'll spend most of the time on Wednesday. So try to do these chain rules here for them. No, the practice exam does not count as a grade. So that was it, it's not worth anything. Everything is worth 0. It was just there so you can see what the exam is like, right? So what is the exam setting going to be like for you? That was the experience. Okay. Any other questions, comments, concerns before we break today? Everybody's good? All right, so we'll call it here, and then we'll meet back same time on Wednesday. And so try to think through these 5, and that's what we'll pick up with at the beginning of class on Wednesday. So stay safe, stay healthy, stay sane. We are gonna get there. We'll get through it together. All right, I'll see you all on Wednesday. You're welcome. See you on Wednesday.